everyone, we are here to present our data structure project on Sudoku Solver and Creator. In this project, we have explored advanced methods like backtracking and used 2D arrays to represent the puzzle grid. We used we also used sets to track used values and we have used stack to show the timer. Our goal is to solve Sudoku and create Sudoku by using data structure and then compare it with other methods. Now let's run our code. So here you can see there are two modes. First says get a Sudoku puzzle and second says provide your puzzles and get its solution. So let's choose one. So example, if you enter 5, the timer is started. Enter 1 to see the result. So this is the solved Sudoku. Now we will run the code for the second mode. Enter your Sudoku puzzle row by row. Enter 1 to see the result. So here is the solved Sudoku which will provide by us.
Now let's see the coding part. For this we are using three files. The first one is the main file, and then we have the game file for solving and creation of the puzzle both, and then we have the stack file for the timer. So for solving the Sudoku, we are first using Boolean masking. It means that whenever we'll get a puzzle, we'll first of all go to all the non-empty values of this grid, and then we'll mark the presence of that number in the column, the row and the grid. So in this case we'll have 2 marked as true for this column, for this row and this grid, and for 3 we'll have this column, this row and this grid. So after this Boolean masking function, this solve Sudoku function will then go to all the empty cells of this grid and will try placing the false values into it. So in this case we'll have 1 and 7 which are not true for this column, for this row and for this grid, and then we'll use backtracking so that after 1 we'll then use backtracking, and then we'll check that no other value should get affected because of this one. So at last we'll have 7 here and we'll have 1 here. So this is about the solving, and then we have the puzzle generation code. So this generate grid function will pick up an empty linked list, and then we'll enter the values from 1 to 9 into it to return a complete generated cell. That is, it will return a grid which has no empty cells, and then this remove numbers will remove a few of the numbers from this completely generated grid to convert it into a Sudoku puzzle. So this is about the generation of the puzzle. So at last we have the timer function. For this we have used stack. So in this case we are simply pushing the numbers from 1 to the chosen duration, and then we'll pop out the values from the stack to make it a countdown timer.
A stand backtracking algorithm recursively explores possible number placements, checking rows, columns, and subgrids for conflicts. A naive approach results in deep recursion, making the algorithm expensive. Here we ask if data structures can make computation less expensive, and in fact, they can. Boolean arrays quickly verify if a number has already been placed in a row, column, or a subgrid, whereas hash sets map each cell to possible values instead of iterating over rows and columns, which prevents unnecessary function calls. Bit masking is an efficient representation which compresses constraint backtracking into integers. Instead of maintaining arrays, we represent numbers using bits and use bitwise operations for checking the number validity. And stack is used for iterative backtracking because as recursion uses space in the call stack, by explicitly using stack, recursion is converted into an iterative process, and it helps when we backtrack using pop. We can easily backtrack. Thank you.